All right, welcome to the Explainer. Today, we're tackling a really cool topic, zero-shot learning. It's this incredible AI idea that's all about teaching machines to think. Well, a little less like a computer and a lot more like you and me. So let's kick things off with a question that sounds simple, but the answer is anything but. Can an AI actually recognize something it has never seen before? And I don't mean just a different color car, I mean a whole new category of thing it's never been trained on. The answer, believe it or not, is yes. And how it does that? Well, it's a total game changer. Okay, so before we get to the magic of how an AI can recognize something new, we've got to talk about its biggest weakness. It's what we call the AI's data problem. You see, most AI systems have this fundamental hangup. They need an absolutely insane amount of data, labeled data, just to learn the simplest things. And this slide really lays it out perfectly. On one side, you've got your standard, traditional way of learning. We call it supervised learning. To teach an AI what a cat is, you have to show it thousands, maybe millions of pictures, each one with a little label that says cat. It works for sure, but man, is it inefficient. But then, on the other side, you've got zero-shot learning. And the goal here is totally different. The AI has to figure out what a cat is just from a description, without ever seeing a single labeled picture. And to put this into perspective, think about this number. Humans, you and I, we can recognize something like 30,000 different categories of objects. Now, just try to imagine the sheer amount of time, money, and frankly, computing power it would take to label thousands of examples for every single one of those categories. It's just not possible, right? There has to be a smarter way to do this. So, if that huge data requirement is the big wall we've hit, how do we climb over it? Well, that brings us right to the solution, learning without seeing. We're about to dive into a totally different way of thinking about AI training. It's a method that's all about genuine understanding, not just brute force memorization. So here's the formal definition, just so we're all on the same page. Zero-shot learning, or ZSL, is when an AI model can categorize things it has never, ever been trained on before. The most important part to remember is that zero in the name. It's not a metaphor. It literally means the AI has seen zero examples of that new category. And this right here, this is the big mental shift you have to make. The key isn't seeing a bunch of examples. It's understanding concepts. Instead of just training a model to recognize a pattern of pixels that looks like a cat, you're training it to understand the idea of a cat. What makes a cat a cat? What are its defining features? It's a huge leap from just sight to actual insight. This is probably the best way to think about it. Imagine how a little kid learns what a bird is. The old way, the supervised learning way, is like showing them hundreds of pictures, each one labeled bird. But the zero-shot way? That's like reading them a description. Hey, a bird is something that has feathers, wings, and a beak. Once they get that concept, they can go out into the world and spot a bird, even if it's a kind they've never seen in a picture before. It's intuitive. So the big question is, how does an AI actually do this? How does it learn from just a description? It's not magic, I promise. It's actually a really clever set of tools. So let's get into it and break down the three main ways AI learns to understand these new ideas. All right, method number one is what we call learning by attributes. This is all about breaking things down into their basic parts. So the AI doesn't learn what a bee is directly. Instead, it learns the attribute has stripes by looking at lots of zebras. It learns the attribute is yellow from canaries. And it learns is a flying insect from flies. Then, when you tell it, hey, find me a yellow, striped flying insect, it can piece all those learned concepts together and identify a bee, even though it's never actually seen one. It's kind of like building with conceptual Lego bricks, right? Okay, the second method gets a little more abstract. This is learning by association. Instead of focusing on physical things like stripes or wings, this method is all about understanding the relationships between ideas. The AI learns not just what a king is, but how the concept of king relates to man, or ruler, or its counterpart, queen. It's all about figuring out where concepts fit on a map of ideas. And the way it does this is with something called semantic embeddings. The best way to picture it is like a giant map of meaning. On this map, concepts that are similar are placed really close together. So the word king would be right next to queen, and puppy would be super close to dog. So now the AI can take a new unseen object, figure out where it lands on this map, and then classify it based on what its closest neighbors are. It's basically classifying by association. All right, now for method number three, and this one is honestly a little mind-bending.
What if the AI, when it doesn't have any examples, could just imagine them? What if it could just make them up? Well, that's exactly where generative AI comes into play. So here's how it works. The model takes that text description we talked about, a yellow striped flying insect, and feeds it into a generative AI, like the systems that create images from text prompts. And that system literally generates pictures of what a bee might look like. It creates its own examples from scratch. In a way, it's turning a zero-shot problem right back into a regular old supervised learning problem. But, and this is the amazing part, it did it all by itself. No humans needed to go find and label photos.
Okay, so these methods are absolutely brilliant in a nice, clean, controlled lab environment. But what happens when you take this AI out into the messy, real world? A world where it's going to see things it already knows and brand new things it's never seen, all jumbled together? Well, that is the real-world challenge.
And this is where we get into something called generalized zero-shot learning, or GZSL for short. Think about our bird spotting AI again. In the real world, it's not just going to see new birds. It's going to see a robin, which it's seen 1,000 times, maybe a squirrel, which it also knows, and then bam, a toucan shows up. The tricky part is for the AI to correctly say, yep, that's a robin, while also realizing that the toucan is something totally new. It has to constantly choose between what's familiar and what's brand new. And this brings us to the biggest hurdle. AI models, at their core, can be kind of lazy. They develop a really strong bias towards the things they've already seen. So if you've trained it on 10,000 pictures of dogs and 0 pictures of wolves, when you finally show it a wolf, its first instinct is going to be, that's a weird-looking dog. The whole goal of GZSL is to fight that bias, to get the model to correctly say, nope, hold on, this is something completely new.
Okay, so we've covered the problem, we've looked at the toolkit, and we've talked about the real-world challenges. But now we get to the most important question of all. Why does any of this matter? What's the big payoff here? Why are we trying so hard to teach an AI to think this way? So here's the bottom line. This whole shift from just seeing patterns to actually understanding concepts, it's huge. Zero-shot learning helps us solve some of AI's biggest problems. It gets around that insane need for massive labeled data sets. Think about how crucial that is for identifying really rare things, like a new animal species or a rare medical condition in a scan. It makes AI way more adaptable, way more flexible, and it slashes the time and cost it takes to build these systems. This isn't just some neat trick for the lab. This is what's going to unlock the next wave of truly intelligent applications. And that really just leaves us with one final, pretty deep question to chew on. If an AI can identify a bird just from reading a description, has it just learned a really clever pattern-matching trick? Or is it actually starting to understand what a bird is? As this tech keeps getting better, that line between just calculating an answer and true understanding, well, it's going to get blurrier and blurrier. Thanks so much for joining me on The Explainer.